One reason why we study one-to-one functions is because every one-to-one function has what's called an inverse function. So I want to define an inverse function for you now. Okay, every one-to-one function has an inverse. That's important. If a function is not one-to-one, then it does not have an inverse. So let's say that y equals f of x is a one-to-one function with a domain A and range B. So maybe I'll draw a little picture here. So let's say there's the domain of f and has a bunch of points over here. And f is going to take everything in A over to the range here, B. All right? So f is a one-to-one function with domain A and range B. Then the inverse function is denoted by y equals f inverse. That has nothing to do with the negative 1 power. Okay? That is just notation. If ever we see f to the minus 1, that means f inverse. So if we have an f function going from A to B, and it's one-to-one, then there exists an inverse function that goes from B to A. That is, the inverse will have domain B and range A. Okay? Furthermore, if f of A equals B, so let's say A is right here, and let's say f takes A to B, then f inverse of B is A. Then f inverse takes B right back to A. I'll do an example. We saw that x cubed is one-to-one, so it has an inverse. It can be shown that f inverse is called the cube root of x. Note, f of 2 is equal to 8, okay? Because 2 cubed, if we shove a 2 into the f function, 2 cubed is 8. Notice what f inverse of 8 is. Well, f inverse of 8 means we plug an 8 into the inverse function, and the cube root of 8 is 2. So f took 2 to 8, f inverse took 8, right back to 2. Now, if you know what the sketch of x cubed looks like, looks something like this. Okay, if you wanted to plot some points and plot the cube root function, it looks something like this. You can go ahead and plot some points and show that. But notice, there's a really nice feature here. If ever we have an inverse function, if I have a function f and its inverse, these functions will always be symmetric about this line right here, that 45-degree angle line, y equals x. Okay? So let's write this down. The graphs of f and its inverse functions are reflections about the line y equals x. So let's do an example. Let's say that this function is one-to-one. Notice it passes the horizontal line test. And it just says sketch the inverse function. Well, what we need to do first is draw the line y equals x. And it's going to be a mirror image about this line. So let's take a look at this point here. That's the point 0, 1. If f takes 0 to 1, then f inverse is going to take 1 to 0, or it must go through that point right there. And if we draw a mirror image about this line, it's going to look something like this. Let's note a couple things. F. What's the domain of our f function? Well, the domain is negative infinity to infinity. The range is from 0. Notice this line means it's never going to quite touch. This arrow means it's never going to quite touch the x-axis. So the range is from 0, not including 0, to infinity. Well, since we know this, we automatically know the domain and range of the inverse. Notice the domain is 0 to infinity. It's never going to quite touch the y-axis. And the range is negative infinity to positive infinity. and that's a property of inverse functions. The domain and range simply flip-flop. The domain of f becomes the range of f inverse. The range of f becomes the domain of f inverse. Okay, so that's one-to-one and inverse functions. We'll continue with a little more on these in the next lecture.